I'm Anil Kumar, and in this video we will understand horizontal asymptotes and limits at infinity. Question is, determine the equation of any horizontal asymptote for the function f of x equals to x plus 1 divided by x minus 1. Then state whether the curve approaches the asymptote from above or below. Now, let us understand what is horizontal asymptote. We are given the function x plus 1 over x minus 1. Horizontal asymptote is basically the end behavior of the function. We try to find limit of the function as x approaches negative large value, which we may say negative infinity. Then, if the function approaches a value, we say it has a horizontal asymptote, right? Similarly, we'll also find limit of the function f of x as x approaches positively large value. If the function approaches a fixed value, we say that is the equation of horizontal asymptote. Now, how do we find it? One way is, now to analyze the equation, of course. Here we see that the numerator denominator degrees are same, and therefore the equation should be ratio of coefficients. But we will show you a method how to find that. So in this particular case, I can take x common in the numerator, x common in the denominator. In that case, what do I get? I will get x times 1, I'm taking x common, plus 1 over x, is it okay? Divided by, numerator gives me x times 1 minus 1 over x, correct? Now we are actually trying to find limit of the function as x approaches large value. Either it is negative infinity or it is positive infinity. So I could have written this as limit of the function as x approaches negative infinity for all this. Now here you can see x and x can be cancelled, so you are left with 1 plus 1 over x and 1 minus 1 over x. We could write this as the limit of 1 plus 1 over x over limit of 1 minus 1 over x. Now applying the rules of limit, we could write this as limit as x approaches minus infinity of 1 plus limit as x approaches minus infinity for 1 over x divided by limit as x approaches minus infinity for 1 minus limit as x approaches minus infinity for 1 over x. Now clearly, for 1 that is a constant, so the limit is 1. And here 1 over x, if x is large, we are approaching 0, so it's 1 plus 0. In the denominator you get 1 as a constant minus 0. So the limit is indeed 1. You get an idea, right? So we get limit of 1 in this case as x approaches minus infinity. If you follow the same steps, what you get here is, we'll do this calculation again so that you understand. So we'll get this as limit of the function, which is, we'll write this as plus infinity. Now we can take x common, we'll follow exactly the same steps, 1 plus 1 over x divided by x, 1 minus 1 over x, correct? Now x and x cancels off, so we can now write this as limit of function as x approaches infinity for 1 plus limit as x approaches infinity for 1 over x divided by limit as x approaches positive infinity for 1 minus limit as x approaches positive infinity for 1 over x. Now that is 1, this is also 1, and these are 0, so we get 1 as your answer. So in both the cases, what you really see, that as x approaches negative infinity or positive infinity, the value of the function approaches 1, and that means there is a horizontal asymptote, right? And the equation of horizontal asymptote is y equals to 1, the value which the function approaches, right? So that is the first part. So what you notice here is, whenever you have a function like this, where degree of numerator and denominator is same, so we can write here same numerator denominator degree, right? In that case, horizontal asymptote will be y equals to ratio of their coefficients, right? Y equals to ratio of leading coefficients. In this case, it is 1 and 1, right? So it is basically 1. So that is how we could quickly get the answer also. Well, that's the first part. The second part is, then state whether the curve approaches asymptote from above or below. Now, what does that mean? It really means this, that what we have really found here is, that is our axis, and what we found is that the horizontal asymptote is 1. So that means the function is approaching this line, which is y equals to 1. Now we need to figure out that when you approach negative infinity or positive infinity, the value is slightly more than 1 or less than 1. That is what you need to figure out, right? So how do you find that? To find that, what we should do is, in the function itself, we can test with a negative large value and positive large value. If we are dealing with constant like 100 is a good value, right? So let us test the value of the function f of x when x is negative 100, that is approaching negative infinity. So if I write negative 100 plus 1 over negative 100 minus 1, in that case, what do I get? I get a value which is less than 1, right? Very close to 1, or it is less than 1. So we can say that it is approaching from below the curve. Do you see that? Now, if I do the same calculations, but for f of x equals to positive 100, let's say positive 100 divided by, minus 1. In that case, what do you notice? This value will be greater than 1, right? So we can say that the function approaches from above the horizontal value. So by testing negative large value and positive large value, you can find out whether the curve approaches the asymptote from above or below. So we can now say that the curve approaches from below as x approaches negative infinity, or the other way to write this is like this. So we could write our answer as like this, that the limit of the function as x approaches negative infinity is equal to 1, but from bottom, right? And the limit of the function as x approaches positive infinity is equals to 1, but from above the curve. That plus and minus clearly indicates that part, right? So let us summarize what we have done in this particular video. We have basically learned how to find horizontal asymptote. The horizontal asymptote is when x is approaching positive or negative infinity. If the function approaches a fixed value, then we say horizontal asymptotes exist, and y equals to that value is the equation of horizontal asymptote. In this particular example, y equals to 1 is the equation of horizontal asymptote, right? So that is the first part. Next part which we understood was how to find whether the curve approaches asymptote from above or below. The best way is to substitute a large value, negative and positive, and check. So if I substitute in this case, large value means 100 times the constant. So constant is 1, so 100 is a good value to check. So if I substitute negative 100, I am approaching negative infinity because 100 is very, very large as compared to 1. In that case, my value comes out to be slightly less than 1. So we are approaching from below the line. When I approach positive infinity, I am substituting positive 100 as a value, right? I am substituting positive 100 as a value. And in that case, we calculate f of x as slightly more than 1. So we are approaching from above the horizontal axis, right? So that is how we could also write our equation. So that negative means approaching from below the horizontal asymptote. Positive means above, right? So that is what it is. In the next video or in another video, we'll consider the vertical asymptotes, and then you can actually sketch this graph. I hope that is very clear. Thank you and all the best.